Learning objectives.
At the end of this topic, you will be able to understand the concept of trigonometric ratios, learn the method to calculate the values of trigonometric ratios, evaluate problems involving trigonometric ratios. Introduction. Let's begin this chapter with some examples. View the images shown. In image 1, we need to find the height of the tower. In image 2, we need to find the width of the river. In image 3, we need to find the altitude of B from the ground. In all the examples seen previously, the distances or heights can be found by using some mathematical techniques which come under a branch of mathematics called trigonometry. Some important points about trigonometry are: the word trigonometry is derived from the Greek words tri, meaning three, and gon, meaning sides, and metron, meaning measure. In fact, trigonometry is the study of relationships between the sides and angles of a triangle. The earliest known work on trigonometry was recorded in Egypt and Babylon. Early astronomers used trigonometry to find out the distances of the stars and planets from the Earth. Most of the technologically advanced methods used in engineering and physical sciences are based on trigonometric concepts. In this chapter, we will study some ratios of the sides of a right triangle with respect to its acute angles, called trigonometric ratios of the angle. We will establish some identities involving these ratios called trigonometric identities. Trigonometric ratio. Before we go into details of trigonometry, let's consider a right triangle ABC as shown in the figure. In the figure, angle CAB is an acute angle. Position of the side BC with respect to angle A. It faces angle A. We call it as the side opposite to angle A. AC is the hypotenuse of the right triangle and the side AB is a part of the angle A. So we call it the side adjacent to angle A. The trigonometric ratios of the angle A in right triangle ABC is defined as shown. Note: tan A is equal to sin A by cos A. Cot A is equal to cos A by sin A. Hence, trigonometric ratios of acute angle in a right triangle express the relationship between the angle and the length of its sides. Symbol sin A is used as an abbreviation for the sine of the angle A. Sin A is not the product of sine and A. Let's go through the history related to trigonometry. The first use of the idea of sine in the way we use it today was in the work Aryabhatyam by Aryabhatta in AD 500. Aryabhatta used the word artha ja for the half chord, which was shortened to ja or jiva in due course. When the Aryabhatyam was translated into Arabic, the word jiva was retained as it is. The word jiva was translated into sinus, which means curve, when the Arabic version was translated into Latin. Soon the word sinus, also used as sine, became common in mathematical texts throughout Europe. An English professor of astronomy, Edmund Gunter, 1581 to 1626, first used the abbreviated notation sine. The origin of the terms cosine and tangent was much later. The cosine function arose from the need to compute the sine of the complementary angle. Aryabhatta called it cotijya. The name cosinus originated with Edmund Gunter. In 1674, the English mathematician Sir John Moore first used the abbreviated notation cos, using the AA similarity criterion. By the property of similar triangles, the corresponding sides of the triangles are proportional. So we have, from this, similarly, this shows that the trigonometric ratios of angle A in triangle PAM is similar to angle A in triangle CAB. In the same way, the value of sin A remains the same in triangle QAN. From our observations, it is now clear that the values of the trigonometric ratios of an angle do not vary with the lengths of the sides of the triangle if the angle remains the same. We have defined 6 trigonometric ratios of an acute angle. If we know any one of the ratios, can we obtain the other ratios? Yes, is the answer. We will understand this with the help of some examples. Given the right triangle below, find sin A, cos A, tan A, secant A, cosecant A, and cot A. Let's move to another example. In the figure below, find C. If x is an acute angle of a right triangle and sin x is equal to 3/7, find the exact value of the trigonometric functions cos x and cot x. Summary. Let's summarize the topic. In a right triangle ABC, right-angled at B, sin A is equal to side opposite to angle A by hypotenuse. Cos A is equal to side adjacent to angle A by hypotenuse. Tan A is equal to side opposite to angle A by side adjacent to angle A. Cosecant A is equal to 1 by sin A. Secant A is equal to 1 by cos A. Tan A is equal to sin A by cos A.